All right, hey everyone. So good afternoon. Hope your day is going well so far. Today is the second day of our vectors unit. So we're going to talk about unit vectors specifically. Your aim is how do we write vectors in terms of the unit vectors, I and j. For you to do now is just an exercise in vector arithmetic, which we saw yesterday. Right. So here you have u and v, and then I want you to find these various quantities. Okay. So take the next minute or so to work on this, and then we will review. Okay, so let me pause you here. Um, at this point, feel free to type in the chat what are your answers for the first three. Okay, so type in the chat what you think the answers are for the first three. All right, so we got 1, -1, 3, -5 for B. And then C, we have 4, -6. All right, very nice. Yeah, that should be correct. Let me scroll up to the solutions. All right, so yeah, 1, -1, right? All you have to do is add the components. So you do 2 plus -1, which is 1, and then -3 plus 2, which is -1. For subtraction, just be careful with the signs here. It's 2 minus -1, which is 3, and then -3 minus 2, which is -5. Next, we have 2u. All you have to do is multiply by the scalar 2, so it's 4, -6, and then -3b. We get 3, comma, -6. Okay. E is, two steps. Here we have to do 2u and then 3b separately and then add them. So we have 4, -6, as well as -3, 6. And then you add them, you get 1, comma 0. Okay. So as a segue, this last result, 1, comma 0, is something called a unit vector. It's called a unit vector because the magnitude of the vector, right? If you remember from yesterday, the magnitude of a vector is calculated using square root of a squared plus b squared, right? If you do that for this vector, then you'll get a quantity of 1. Okay, which brings us to our definition for today, which is right here. All right, can someone read this definition first, please? You volunteers.
A vector of length. Oh, I hear myself. Whatever. A vector of length 1 is called a unit vector. For example, W equals 3/5, 4/5 is a unit vector. Two useful unit vectors are I and J, defined by I 1, 0, and J 0, 1. Any vector can be expressed in terms of I and J. The vector V A and B, A comma B, can be expressed in terms of I and J by V A comma B equals AI plus BJ.
All right, thank you for that. So yeah, just a few things. Again, the definition of a unit vector, it's a vector of length 1. Technically, there are infinitely many unit vectors, but we're going to look at 2 in particular in this class. The first one is I, which is 1, comma 0, which is the horizontal unit vector. And then J is the vertical unit vector, right? 0, 1. If you graph them 1, 0, it's going to be located, it's going to point eastward, right? And then J is going to point vertical, right? It's going to point up, right? So 0, 1. So in other words, yeah, there's a right angle. They're orthogonal. There's a right angle between them. and any vector can be expressed in terms of I and j. So the point of this, you might be wondering like why we're doing this in the first place. The point of this is just another way to write vectors. So it's just a matter of notation. So as we saw yesterday, right, this is one way to solve, or sorry, not solve, see a vector, right? We have the v brackets, which is, 0, comma 1. If you take linear algebra next year in school or in college, right, there's another way to write vectors. You can write it as actually a one column matrix. Okay, so this j vector can be written like that, right? Or you can also use parentheses, right, for 0, 1. And then the way we're going to look at today is through unit vectors, right? So technically j is 0i plus 1j. Okay. But yeah, any vector can be expressed in terms of I and j, as you'll see. And yeah, you just do ai plus bj. Nothing like conceptually profound here, but just, just a matter of notation, okay? Okay. And as another reminder, the magnitude of a vector, you do square root of a squared plus b squared. Yes, question?
Wait, maybe I'm missing something. Why W equals 3/5, comma 4/5 a unit vector? It's
Yeah.
totally
So, wait, what about that vector?
it's a unit vector because if you like solve for the length. Okay, so it's like the length between the two points, right? Or whatever.
Yeah, yeah. So that's the only defining factor to it. So like, if you do, square root of 3/5 squared plus 4/5 squared, then you get 1, right? Because 3/5 squared is 9 over 25, and then 4/5 is 16 over 25. If you add them together, you get 25 over 25, which is 1. Square root of 1, which is 1. Yeah. Yeah, that's the only thing that makes a unit vector a unit vector. Yeah. Okay. All right. Anyone still copying this definition? Please speak up or type in the chat. Okay. Now I'll move on then. Oh. Okay. All right. Next example is just pretty simple. It's just yeah, how would you express the vector 5, 3 in terms of I and j? Exactly how you think it is. It's just 5i plus 3j. Okay, that's all it is. Outside of that, let me follow up with this group work question, which I would normally have you do in class, but with the shortened periods, I'll just go through it right now. So here we have u equals 5 comma 3 and v equals negative 4 comma 6. Write 2u plus 5v in terms of I and j. Okay, so 2u is 10 comma 6, 5v is negative 20 comma 30, right? And then if you add them together, you get negative 10, right? So 10 minus 20 is negative 10, and then 6 plus 30 is 36. And if you express that in terms of unit vectors, you get negative 10i plus 36j. Okay. The advantage to writing in this notation is that it lends itself to thinking that like you're adding vectors. If we look at even this question right here, right? You could see this as 10i plus 6j and then negative 20 plus 30j. So you're kind of like just adding the building blocks, where the building blocks are like I and j, those unit vectors, right? So everything can be broken down into these unit vectors I and j, and then all other vectors are built from this, right? It's kind of like the concept of like elements in chemistry, right? Everything can be broken down into elements, right? Yeah, same idea here. Okay, is anyone still copying these two problems? You gonna type in the chat or speak up? Okay, if not, then I'll move on. Okay, next we're gonna have a more robust, more versatile way to represent vectors. Namely, we're going to involve the angles now. Okay, so in your notes, I do want you to draw this diagram here. So here you have your x and y axes, you have magnitude v cosine theta, and magnitude v sine theta. Okay, and yeah, so we let v be a general vector, right? AI plus bj, and then so yeah, you don't have to copy this down. I'll tell you what to copy. It's just the notes right here, but just do copy down the diagram. So cosine theta, right? As you know, it's adjacent over hypotenuse, so it's I'll call the horizontal component a, right? So cosine theta equals a over magnitude v. Sine theta is opposite over hypotenuse, so that'll be b. Let's call that b, right? Well, b from this, right? A and b from this. It's b over magnitude v. Okay. From there, you can cross multiply, so you get a equals magnitude v cosine theta, which we have here, and then b equals magnitude v sine theta, which we have here. Okay. From there, we just substitute, right? So we know that this vector can be written as ai plus bj, right? Any vector, and we're going to substitute to get magnitude v cosine theta I plus magnitude v sine theta j. Okay, so this allows us to write this in terms of an angle, which we normally have like, yeah, we're not restricted to just like the x and y directions. Okay, all right, but yeah, for your notes, please copy this down. Okay, any volunteers to read this?
Let v be a vector with magnitude, absolute value of v, and direction theta. Then v is the vector AB, where AI plus BJ. I don't know how to do this.
For this part?
Yeah.
Yeah, you just say a equals magnitude v cosine theta and b equals.
A equals magnitude cosine theta and b equals magnitude sine theta. Thus we can express v as b equals the magnitude of cosine theta I plus magnitude of sine theta j.
Okay, thank you for that. Yeah, so this is like the form of a vector that we're going to look at in the next few lessons, right? So yeah, we're going to have the magnitude and then the angle, right? Some keywords here that you'll see in these problems is, magnitude is, square root of a squared plus b squared, if you remember from yesterday. And then direction is a new like word they're using. You'll see this in the homework problems. Like direction, just think of angle. Okay. Right there. Right. Okay. Does anyone still need the notes here? You can speak up or type in the chat. Okay. Not, then I'll move on. So actually, I wanted to. Well, the last part of the lesson is just 2 questions for classwork. But before I do that, let me ask you this question. So the poll on your screen right here. Okay, so which of the following is a unit vector? Okay, so here we have 3 choices. Before you answer, let me remind you that, again, a unit vector is a vector of length 1, and then when we find the length or magnitude of the unit vector is, or the vector, is square root of a squared plus b squared. Okay, and if that equals 1, then it is a unit vector. Okay, so with that in mind, go ahead and answer the question. All right, we currently have 7 people who have answered. I'm gonna wait for a few more. Let's try to get to half at least. All right, take another 20 seconds. Okay, so I'll pause you there. So the answer is C. Okay, so which most of you got good. If you didn't get it, that's okay. This is a still a new concept. But yeah, let me show you the solution. Okay, so again, the answer was C. So the way we're going to do that is, or approach this problem, is to calculate the magnitude for each of these vectors. So 2 is the obvious one. It's just like it's I, right? It's the horizontal unit vector, which we saw. But for the others, we need to do square root of a squared plus b squared, right? So magnitude of 1, it's going to be square root of 1/9 plus 4/9, right? If you square both quantities, which is the square root of 5/9, which is not equal to 1, so that's not a unit vector. For 3, you have square root of 2/4 plus 2/4, which is the square root of 1, which ends up being 1. So both 2 and 3 are unit vectors, which makes the answer to this choice C. Okay. All right. I'll give you a sec to copy that down if you need it. But other than that, we'll just have the classwork questions. Okay, anyone still need the solution here? All right, let me move up then. So just 2 questions. So here the first one was a vector v has length 4 and direction pi/6. Write v in terms of I and j. Okay. So just as a reminder, direction, that's just another fancy word for angle. Okay, so if you remember from the notes here, right, direction is angle. And we're going to use this notation, right? So v equals 4, right? That's length 4. Another word for length is magnitude, right? So 4 cosine pi/6i plus 4 sine pi/6j. At this point, you just evaluate cosine pi/6 or cosine 30 degrees is √3/2. Sine 30 degrees is 1/2. So you're going to end up with this. Simplifying, you get 2√3i plus 2j. Okay, that's number 1. Okay, all right. I'll move on to question 2. Question 2 is find the magnitude and direction of u equals -√3i plus j. Okay, so magnitude is just square root of a squared plus b squared. Square root of a squared is going to be -√3 squared, which is positive 3. And then here it's just 1, so it's 1 squared, which is 1. So it's square root of 4, which is 2. Okay. For the angle or the direction, as they use the word here, the formula is tan theta equals b over a, right? If you remember. So we didn't explicitly state that in this lesson, but yeah, like if you draw the vector out, right, it's going to be so -√3 plus j, it's going to be located right there, right? So in the second quadrant. But yeah, the horizontal component is root 3, the magnitude at least, and then here we have 1. So you find the angle using tangent, right? So b over a. So the opposite is 1, and then the adjacent side is root 3, but it's negative. To rationalize, you do root 3 over root 3, multiply, and then you get negative root 3 over 3. At this point, just remember that the angle that makes tangent root 3 over 3 is 30 degrees, right? That's the reference angle, but since this is negative, it's going to be in quadrants 2 and 4. But as we see from this diagram that we drew, it's going to be in quadrant 2. So the angle is going to be 5 pi over 6 for the angle, right? 11 pi over 6 is the other option, but that's quadrant 4, and we know that this vector is not in quadrant 4, so it's 5 pi over 6. Okay, so final answer, magnitude is 2, and the direction is 5 pi over 6. Okay. All right, so while you finish copying that, let me close with announcements. One, there is SGI today, per usual, 2:47. Secondly, as I said yesterday, so next 2 Fridays we don't have school. So because of that, I need to quiz next Thursday. Now, I want to ask, does anyone have like another quiz or essay or project due next Thursday?
Yeah, I also have another one on Thursday.
Okay. Is it an essay or a quiz or what?
It's a quiz.
Okay.
I mean, it's fine.
Okay. Yeah, it's just like I was thinking either that or Wednesday. I don't know if Wednesday would be better.
I think Thursday's fine.
Thursday. Okay. All right. Yeah, let's do Thursday. I'm sorry I have to do this, but yeah, it's just no school the next 2 Fridays. So yeah. So but yeah, I'll send the topics list over the weekend. But yeah, next quiz will be next Thursday, right before the midwinter break.
Have a good day.
Yeah. All right. Take care. Yeah, you're free to go. I'll see you all tomorrow.
Thank you. Have a good day.
Thank you.
All right. You're welcome.
Bye.
All right. Bye.